In 2011, a study was conducted about the potential spillback of
Myxosporium parasite Myxosporium immersum, hypothesized to have been introduced by the invasive cane toad, consequently contributing to the rapid decline of native amphibians. Hartigan et al. Investigates this issue. Two species of Australian native frogs were taken from a semi-captive breeding ground. Major internal organs were harvested for investigation, inspected for myxospores. Similar processes were performed on the introduced cane toad, Hawaiian cane toad, and 10 Brazilian cane toads that contained a known species of Myxosporium parasite, Myxosporium cf. immersum. The known species was used for the comparison of myxospores found. Investigation was started looking into the change in behaviour of green and golden bell frogs. Both species have experienced rapid decline since the 1980s. Within the bile ducts of these tested green and golden bell frogs, organisms were identified as seen in Figure 1. These were consistent with Myxosporium plasmodia. Myxospores that were harvested were morphologically resemblant of the species immersum. Due to this apparent ability of the immersum species to cause disease in at least two species of native frogs, the Australian Registry of Wildlife Health was surveyed, and 26 cases within 9 native species were reported for exhibiting symptoms. Transmission electron microscopy of the brain stages show extraspogonic developmental stages, exclusively within myelinated axons, which were 3 times larger than the average size. Figure 2a shows the multinucleated cell. Extrapogonic stages were seen to extend to the absolute periphery of the axon, causing swelling of the axon and lesions obstructing the neurological function. This was estimated to be the cause of behaviour changes recorded. This was also seen in 12 of the 22 spinal cords of South American toad. Further genetic characterization was needed to identify this correlation. The sequence analysis confirmed that the presence of Myxosporia in both brain and liver tissues, Myxosporium spp. The SSU RDNA sequence, as seen in the phylogenetic trees of Figure 3 and 6, gave a complete match between the myxospores within the native species, but not of the invasive cane toad. Both figures showed the correlations and differences between myxospore species and the various hosts. To determine whether both genotypes were present in other species, the researchers collected a quantity of striped marsh frog from the same location. The symptoms were identical as were the genotypes of the myxospores found. Figure 4 provides an idea of what the particular myxospore looks like. Morphology, it was found that the Myxosporia found in the Australian frogs belonged to the genus Myxidium. In the striped marsh frogs, Myxidium myxospores in the gallbladder had no detectable brain lesions, and it was identified as the liver genotype, whereas the southern bell frog with the brain Myxosporian development were identified as the brain genotype. The cane toad examined appeared to be morphologically indistinguishable from both liver and brain genotypes. In conclusion, it was not entirely clear as to where the parasite originated. However, accurate species identification was determined to be critical for correct wildlife management, as well as having major implications for diagnosis, prevention and control of disease agents in animals and humans.